Alright, in this video I will be dividing polynomials using long division. So when it's set up like this, we put the 2m plus 2 in the front, and we make our division sign, and I put this part underneath. Watch out for missing terms. I see cubic, quadratic. The linear term is missing. The x term is missing. So I'm going to have to put a placeholder there. So I have 2m to the third power plus 2m squared. Now here comes the placeholder term. Alright, so I'll say plus 0 m. Yeah, and then the constant minus 8. Alright, so make sure you use a placeholder for any missing terms. So now what you do is you look at the first term of each expression and you ask yourself, 2m times what will give me 2m to the third power? That would be m squared. So which I see m squared column is over here, so I will line it up. Okay, so once I have this, I take it and I do the distributive property with it. Alright, I do m squared times 2m, and of course I'm going to get 2m to the third power because that's what I wanted. But I will also do m squared times 2. That will give me 2m squared, which matches this, but that won't always be the case. That is a coincidence. Okay, so I'll go ahead and draw this line. Now I'm going to subtract by changing the signs. So I'm going to make this minus, and I'm going to make this minus. Now these are always going to cancel out. In this case, these also cancel out, but that's rare. That usually doesn't happen. So that leaves me with 0m minus 8. I just bring the rest of it down. And then I start over again. Now look, 0m doesn't really exist, so I really don't need to bring it down. Now, so we're finding ourselves at the end. Okay, we're already down to the constant term, and you know, 2m times what is going to give me negative 8? Nothing. Alright, this is a lower degree than this. So this is the remainder. So the m squared is the answer, as long as we include the remainder as well. So the answer is going to be the m squared that we have right here. And then we have plus, and we put this remainder over the divisor. So it will be negative 8 over 2m plus 2. Or I could take that minus and I could have put it here instead. But that is the answer to number 9. Alright, it was a little bit weird, but it's okay. Let's take a look at this one, see if it's a little bit more normal. So I'm going to have my 7n plus 9 out front. Okay, 3, 2, 1, 0. So nothing's missing this time. So 7n to the third power plus 30n squared plus 41n plus 28. Okay, so I'll ask myself, 7n times what will give me 7n to the third power? Answer, n squared. Going to line it up with the other n squared. Once I have that, I do the distributive property with it. I go n squared times 7n, that's going to give me 7n to the third power, just like I wanted. But I will also do n squared times 9. That will give me 9n squared. Alright, now I will subtract these by changing the signs. So this will become minus 7n, this will become minus 9n squared. Now these will cancel out. Here, 30 minus 9, that'll be 21. So I'm going to have 21n squared, and then I'll just bring down the rest of this. So plus 41n plus 28. Then I start over. 7n times what is going to give me 21n squared? Well, 7 times 3 is 21, so I'm definitely going to have a 3. And then n times n will give me n squared. So 7n times 3n will give me 21n squared. So that's why the 3n. And of course, I will now distribute. So I will take my 3n and I will distribute like this. 3n times 7n is 21n squared. 3n times 9 is 27n. Now I will subtract by changing the signs. So I'll make this minus and I'll make this minus. These cancel out. Now 41 minus 27 is 14, so I'll have 14n plus 28. Alright, so now I start over. And 7n times what will give me 14n? Well, 7 times 2 is 14. So 7n times 2 will be 14n. And then, once again, I will take my 2 and I will do the distributive property with it. Alright, of course 2 times 7n is the 14n that we wanted, but 2 times 9 is 18. I will subtract once again by changing the signs. These cancel. Now 28 minus 18 is 10. And that's it. Once you get to the constant term, you're done. This is the remainder. Alright, so the final answer is going to be what you see here in pink. But then you will sort of add on the remainder over the divisor. It will be 10 over 7n plus 9. But I'm going to write the whole thing over here. So the final answer is n squared plus 3n plus 2 plus 10 over, remember, 7n plus 9. Okay, so this is the answer to number 10. Alright, let's go on and also practice dividing using synthetic division. So synthetic division only works when you really want to have a linear term here. So you don't want it to be squared or cubed or anything like that. And it's possible to do synthetic division when there's a number in front, you know, like as if this was 2n plus 5, but that's very difficult and involves fractions. So it's probably best to only try synthetic division when there's no number in front. The leading coefficient is 1. So anyway, the way you do it, if I took this n plus 5 and I set it equal to 0, I would get n equals negative 5. Well, this is what's going to go in my box for synthetic division. Okay, so synthetic division starts off with a box like this. And like I said, the n plus 5 is going to give me a negative 5 here in the box. Now I'm going to deal with the coefficients here. Let me scan and make sure I'm not missing any terms. 3, 2, 1, 0. They're all there. If there are ever any missing terms, you are going to have to put in a placeholder. So I'm just going to do the coefficients. So I've got 4, and I've got 30, and I've got 57, and I've got 38. Alright, so you set it up like this. Alright, first you just bring the first one down, and then you multiply and put it in the next spot. So 4 times negative 5 is negative 20. 30 and negative 20 make 10. So 10 times negative 5 is negative 50. Alright, add these up and you get 7. 7 times negative 5 is negative 35. So put these together, you get 3. 3 is the remainder that in the box here. Now if I put the variables back in, start from right here. This is going to be the constant term and the linear term and the quadratic term. So this will be just a number, and then this will be x, and this will be x squared. So that means this will be 4x squared plus 10x plus 7. And now my remainder, I take my remainder and I put it over my divisor. So I'm going to say plus 3 over n plus 5. Okay, so this is the answer, which, by the way, is the exact same thing we would have gotten if we had done long division. Alright, let's practice that again. So if I were to set this equal to 0, I would get p is equal to 6, right? So that's what goes in the box, 6, positive 6. So let's do that. So I'm going to put 6 in the box. 3, 2, 1, 0. So just checking to make sure I have no missing terms. So I have 6, and I have negative 32, negative 22, and negative 7. Alright, the 6 comes down. 6 times 6 is 36. Subtract, and you get 4. Alright, 4, well, I'm adding. Negative 32 plus 36 is 4. 6 times 4 is 24. Alright, combine these and you get 2. 2 times 6 is 12. So put these together and you get 5. Alright, working from right to left, this is the constant, this is the linear term or the x term, and this will be the quadratic term, x squared. So if I put those variables back in, I will have 6x squared plus 4x plus 2. And then the remainder, 5, I put it over p minus 6. So I'll put plus 5 over, whoa, I was supposed to be using p's, not x's. Did I do that over here too? I'm going to have to go back and fix that. Okay, p minus 6. Alright, I accidentally put x's in here. But these are p's, so it's got to be p squared and 4p. That's the answer. Alright, let me go back and fix number 11. These are n's, like I did here. That was weird. Okay, that's better. Alright, so that's synthetic. Alright, I guess that's it for synthetic.